Hey guys, BuildZoid here, and today we're going to be taking a look at some modifications that I made to my GTX 1080 Classified in order to get the core voltage regulation to be more comparable to the Galax GTX 1080 Hall of Fame PCB. So let's get into it, starting off with the measurements. On the very left, we have the stock GTX 1080 Classified PCB with no VGroup running Firestrike Graphics Test 1. On the very right, I have the Galax GTX 1080 Hall of Fame, again with no VGroup, also just running Firestrike Graphics Test 1. And in the middle, we have the modified classified GTX 1080, no VGroup, running Firestrike GT1. So, let's just go over. So average voltage. So average voltage between these isn't perfectly matched. The stock classified was 1.05 volts. The modified classified was 1.04 volts. This might be because it was slightly thermal throttling because I didn't like max the fan speed enough or something. The heatsink on the classified is kind of terrible. Like, for how big that heatsink is, it's really disappointing. Like, the cooling performance is really quite disappointing. And then the Hall of Fame ran at 1.046 volts. So close enough to the classified. The modified classified was running a bit low. Though the running a bit low might also be just because this has so much less overshoot that the average voltage got pulled down. So anyway, yeah, so the average voltages aren't perfectly matched, but they're within 10 millivolts of each other, so I don't think that's a huge deal. So now let's take a look at the minimum voltages. So the 1080, like the stock classified, was on average 943 millivolts of undershoot. The worst case scenario undershoot was 905 millivolts. The Hall of Fame, 951 on average, 921 worst case scenario. So about, 15 millivolts, 16 millivolts better than the, well, 10, like about 7 on average. Actually, it's like 8 on average and like 15 for worst case scenario. The modified classified got 950 on average, 925 worst case scenario. So even better than the Hall of Fame, and that's with a lower average voltage. So that's cool. I wasn't really expecting to get such a big improvement out of my modifications. Anyway, let's talk overshoot. On average, the classified was 1.19 with a worst case scenario of 1.235. The Hall of Fame was 1.17 with worst case scenario of 1.21. The modified classified was average of 1.15 with a worst case scenario of 1.19. Basically, the worst case scenario on the modified classified is the same as like average on the unmodified classified. So that's kind of insane. Unfortunately, it doesn't really matter. In my experience, overshoot doesn't like it does. It looks really ugly on your oscilloscope measurements, but it unfortunately doesn't really affect overclocking very much. So having less overshoot doesn't really translate into like more stability or better overclocks. It doesn't hurt anything, but yeah, like I don't really think yeah, this is like it's a huge improvement, right? 40 millivolts less overshoot. I don't think this is going to translate into some huge overclocking advantage though. Even though like it really sounds very impressive. It's just like, it's overshoot. It doesn't really matter that much in the first place. So whatever. Anyway, and also yeah, like the modified classified beats the Hall of Fame on overshoot as well. So let's talk peak-to-peak measurements. Now, peak-to-peak measurements are not great in my opinion because they are based on the time, like they do depend on the time scale of the oscilloscope, right? Because the peak-to-peak measurement is measured from like here to here within the capture window. So if you have a bigger capture window, like 10 milliseconds per division, you get more peak-to-peak up to a point, right? Obviously, at some point, more time per division isn't going to increase the peak-to-peak measurement anymore. But generally speaking, like 10 milliseconds does measure worse than 5 milliseconds. So that's worth keeping in mind with peak-to-peak. Also, peak-to-peak doesn't, like from a stability perspective, we care about undershoot. So the peak-to-peak measurement is like it has a bunch of overshoot mixed in, which is like, yeah, whatever. Who cares? But anyway, the peak-to-peak is a number that you look at to make yourself feel good about your modifications. So anyway, The classified on average was 250 millivolts with a maximum of 287. The Galax Hall of Fame was 220 millivolts with a maximum of 220 of like 266. And then there's of course the modified classified, which beats both, with an average of 200 millivolts peak to peak, and worst case scenario of 252. Yeah, like crushing the overshoot as much as I did makes the peak to peak measurements way better. How unsurprising. So anyway, yeah, pretty, like, I'd say solid improvement. Like, honestly, it kind of looks like the modified classified might actually be better than the Hall of Fame at this point. So obviously what I need to do is modify the Hall of Fame next. I'm not really gonna do that, but well, I might. Like, there's some easy, like, some, because on the classified, I kind of went to town. Not as to town as I've gone on, like, reference PCBs in the past, but, because it is still a classified PCB, I do kind of, like, I want to, as much as the heatsink is terrible, I do like how it looks. So, like, I didn't want to do any modifications that would, like, require, like, would be incompatible with the backplate or incompatible with the heatsink. Right, and that's also like on a note, because I saw a comment that's been deleted at this point, but I saw a comment that was like, "Oh, how can some guy on YouTube improve the voltage regulation more than whatever EVGA managed from the factory?" Well, see, EVGA has to worry about things like heatsink compatibility, also the like design restrictions from NVIDIA, like the 1080 classified, other than the fact that there's two BIOS chips over here, this is basically a reference 1080. Like, because you don't really get to modify this very much if you're an NVIDIA board partner. Like, this area right here is pretty tightly regulated by NVIDIA. You can do whatever the hell you want over here. NVIDIA doesn't really care. But this, yeah, you don't really get to play with it very much. So yeah, whereas I don't have to worry about NVIDIA and heatsink compatibility and, mass production like requirements. I can stack capacitors on top of each other all day long. A factory really doesn't want to do that, generally speaking. So anyway, let's go into the modifications. So the first thing I got really excited about with this card is that I noticed that over here we have a ground polygon, and over here we have a Vcore polygon. So you know what that means. If we just remove the solder mask in this area, we can throw capacitors across that. So I did that. And that's basically the most intrusive modification that I did on the card. And then on the back of the card, well, there's an awful lot of space in between these 0402s. And I regret noticing that because doing that soldering absolutely massively sucked. I ended up replacing these two with higher capacitance SP caps. I also stacked an extra capacitor on top of this one. I didn't stack anything over here because this is where I'm taking my measurements. Also, I ended up replacing both of these because when I was doing the 0402s, I ended up using a bunch of hot air in the area, and I think I kind of cooked the 330s. I'm not 100% certain that I cooked them, but I probably cooked them. So I ended up replacing them, right? After I did the 0402s, I put new capacitors in the area because, yeah, I wasn't sure if these survived the process of doing the 0402s. And then I also stacked some extra capacitors over here. There's a bunch of empty space over here that we can stack capacitors into, over here and over here. Well, not that much because there's this thing over there. Unfortunately, if you're looking at this and like, oh, is this ground? Yeah, no, that's not ground. That's memory power. So as much as I would have loved to like scrape solder mask over here and then just throw in a bunch more multi-layer ceramics in, I can't do that because this is memory power. That's not a ground plane. So that kind of sucks. There does seem to be like a little ground polygon somewhere in this area, but I think a lot of these vias are like memory signal lines, so I don't really want to take the solder mask off this area. Yeah, this just looks too risky to scrape at, so that's a bit unfortunate. This over here isn't ground either. This, I think, is the PEX power plane, or like a PEX polygon, not really a plane. Um, this might be ground. So what I could have done is maybe thrown some multilayer ceramics over here. I can't put polymers because the polymers are too tall to fit under the backplate, which you'll see what I mean by that soon enough. So that's sort of the plan that I went with for this card was like, okay, we'll add some 0402s, stack some polymers, and then stack some half-height 0805s, because it's kind of one thing that, like, I suspect is not ideal about this card is because EVGA has a relatively low-sitting backplate. All of these 0805 multilayer ceramics on the back are half height. They're not full-size 0805s, so they're lower capacitance than what you get on the Hall of Fame in the same positions. Or at least I think they're lower capacitance than what you get on the Hall of Fame, which is obviously not ideal, because more capacitance, more better. And then another thing is the Hall of Fame uses 560s over here instead of 330s. Yeah, so like EVGA with the classified, like I'm not super impressed with what they did over here. Like even within the limitations of what NVIDIA allows, like you can use better SP caps back here, but EVGA didn't. And if the backplate didn't sit so low, or if they added some extra cutouts into it, you could have had higher capacitance multilayer ceramics. But EVGA didn't. And the reason the backplate sits so low is because EVGA evidently wanted this card to be like 4-way SLI compatible, whereas Galax didn't care. Their card is like 3 slots thick, and yeah, it's not going to do 4-way SLI anyway, so who cares if the backplate sits a bit high. Also, I think the backplate on the Galax card is actually thinner. Like, it has more geometry to it, but I think it's actually like a thinner backplate, which accommodates the extra capacitors, like the taller capacitors better. But anyway, let's take a look at the actual modifications. Also, the donor board. Because, yeah, I don't have half-height 0805s, and I didn't really feel like buying new ones. So I just stole them off of a dead Vega. I didn't kill this Vega. I've, like, a bunch of I have a bunch of dead Vegas because, fans of the channel have sent me a bunch of dead Vegas. They're kind of common for some reason. But yeah, dead Vegas are an excellent source of spare parts. The SP caps on these things are great. I didn't use any of the SP caps off of the dead Vega on this 1080, but like I have like a 980 Ti reference card that has like a dead Vega of SP caps on there. And that helped quite a bit. So yeah, dead Vegas are an excellent source of parts. You get like the multilayer ceramics on these aren't amazing. These are like 22 microfarad instead of like, you can find cards like say 290Xs behind the core have like 47 microfarad 0805s. But if you want half height 0805s, Vega's kind of the best. I'm not aware of another GPU that uses a bunch of half height 0805s, except of course the 1080 classified. But like if you're like, I don't use one of these as spare parts. Like, I don't mind if you take a saw to it so that you, like, you know, cut off the VRM and build an e-power out of it. But don't steal capacitors from a dead classified card. I mean, steal these once you've cut the VRM off, but, you know, yeah, don't steal these. Actually, if you're making an e-power out of it, desoldering these so that you have a better power connection might actually make sense. So maybe do steal them, but like, you know, have a good reason for it. Don't just use this as a parts board. So anyway, yeah. So now the one downside to like using salvaged capacitors is that soldered really doesn't stick to them very well, and you can kind of see why. Like you can see how these pads that are like fluxed are all nice and shiny, and even the unfluxed ones are still pretty shiny. But if you look at the end caps of the multilayer ceramics on here, you'll notice that they're very dull gray. They're like very oxidized. Solder really doesn't want to stick to them. I think if you gave them like a really long bath in some flux, or maybe even just a straight up acid like vinegar or something, might be able to clean them. I don't know if vinegar wouldn't compromise the capacitor itself, though. But yeah, that's a real problem with salvaged capacitors, especially if you have like really old cards that are like ancient, like HD 7970s or something. Or if the card was just in a really high humidity environment. Yeah, like the capacitor caps end up very oxidized, and they don't like solder doesn't stick to them very well, which is annoying with salvaged capacitors. But oh well, you can still use them. Like the pads that are towards the PCB, those still like hold solder just fine. Like solder sticks to those very happily. But yeah, the pads that are like away from the PCB, those suck. Those really don't want to have solder stick to them, though. Again, with a lot of flux and heating, you can eventually get them to behave. But yeah, that's like annoying with salvaged parts. Whereas fresh capacitors are fresh, so they don't have any oxidization on them yet. Because they don't come pre-oxidized from the factory. That would be kind of stupid. But yeah, on old cards, because the thing is, like, the back of the board, right, this is going to sit at, like, when the card is running, it's sitting at, like, 70, 80 degrees. Um, and so, yeah, like, the solder back here just oxidizes a lot faster because of the elevated temperatures. And then when you go to desolder them, you're using hot air, and that makes it even worse. So, um, yeah. But anyway, let's move on to the modifications of this 1080. So on the front, scrape the solder mask. Just use some sandpaper for this. Obviously, careful not to hit the PCIe lanes. And also, I use water when doing this. Like I just put drop of water. Obviously, make sure that like stuff doesn't go under the core. So I usually do like blue tack around, so you could use like Artist's Eraser as well, but I usually use blue tack because you can just buy that in a store here in the UK. And yeah, and then just scrape away, and then once I'm done with the scraping, remove the blue tack because it will melt if you start soldering or something. Like it'll make a horrible mess. But yeah, after I'm done scraping the solder mask, just flux over it, tin it, and then throw some capacitors on there. And I could have gone way further here. Like, I could have extended this out with some wires to, like, put more over here. Also, these are half-height 0805s, and you can see the whole, like, oh, the solder doesn't want to stick to them, right? Like, you see that really sharp line right there? How the solder is supposed to, like, you're supposed to get, like, this nice, like, the solder, like, wicks onto the pads, and that just doesn't happen properly with salvage capacitors. It just doesn't. Unless, like, well, it doesn't happen easily. Like, I didn't want to put a bunch of heat through this area, and I also didn't really want to make a massive mess with flux, because I didn't want to have like a bunch of have to do a bunch of cleaning. So, I was being a bit economical with the hot air and the flux in this area. So yeah, the soldering quality looks horrendous. I might do something about that. Also, I went with the half-height 0805s back here because of the heatsink, right? Like, I'm not sure that the cold plate would clear full-height 0805s, even though I think these are actually under the back plate. I mean, under the cold plate, though. I don't know what's going on with that. Like, this is the ground side, so that doesn't matter if it touches the heatsink, but, like, yeah, I'll have, like, I'm not sure what that is. It might just be some kind of, actually, it might be flux residue. Probably flux residue. Anyway, so yeah, not super proud of it, but it works. Electrons don't have eyes, so they're not going to complain about this, even though it hurts mine. Anyway, let's move on to the back of the card. This sucked. Oh, well, okay, these sucked to do. Also, this does give me anxiety. So the thing is, usually the way I like to do multi-layer ceramics is I like tack down, like hold the capacitor that I'm adding with tweezers, and then, come in with the soldering iron, tack one side, then do the other side, and then just go from there. I don't have any soldering iron tips skinny enough to fit in between these 0402s. Also, these are alternating polarity. So we have ground, voltage, ground, Vcore, ground, Vcore, right? So if this touches this, that's a short, which is why this gives me anxiety. Like there's very clearly a gap there. So like a 1 volt isn't gonna jump that, but even 2 volts isn't gonna jump that. But not even 12. Um, but like yeah, that does concern me. I might end up retouching that, which is gonna be a massive pain. But anyway, so I don't find enough tips. So my like original idea of like, oh, I'm just gonna tack down one side and then I'm gonna come in with the hot air to like clean everything up. Yeah, that didn't work because I kept bridging like capacitors together. So then I had to do everything with the hot air. And like hot air works great when you're putting like one SMD component onto the footprint of one SMD component. It doesn't work so good when you're trying to squeeze two capacitors on a footprint for one, right? Um, because the surface tension of the solder just keeps pulling everything all over the place. Also, these capacitors are like salvaged capacitors, so the solder doesn't even really want to stick to them properly. Yeah, I spent a long time with the hot air and tweezers just like trying to nudge these stupid things into position. I don't think that was worth it. Especially because the 0402s that I pulled off of that Vega are just 1.2 microfarads. Um, so yeah, kind of disappointed in myself for deciding to do something so tedious for like I would not be surprised if almost all of the improvement that we saw in the oscilloscope came from the extra 0805s and the extra SP caps. Um, Also, this isn't anything to worry about. That was just some dust. Or like paper because I use like I use paper towels to like wipe away the flux. So I have some like leftover paper towel there. Um, Also, I did clean this up, though this isn't even a short because this is all ground over here. But oh well, I did end up cleaning that up anyway. Um, yeah, but you can also see like this one doesn't even look like it's attached. It very well isn't. It may very well not be attached. I'm not dealing with it at this point. I'm done. This sucked way too bad. Like it's attached enough that when I cleaned the flux off, it didn't come off. So that's good enough for me at this point. Because yeah, this absolutely sucked to do. Also, because I was blasting this area with hot air, I ended up replacing the 330s back here. This one's stacked up. So yeah, like the 0402s. I wish I was better at this. That's my problem with it. This isn't like, oh, I think this was a terrible idea, totally not worth it. It's like it was a terrible idea, not worth it because I am bad. If I was better and if I had more practice cards, because here's a really wild idea, okay? You see how we have these like strips of Vcore and ground in an alternating pattern? Imagine if you just like depopulated this entire area, right? And then you came in with the sandpaper and you exposed all of that. You'd have a massive short circuit hazard. But anyway, but okay, you carefully exposed it somehow, like, just absolute like pinnacle of precision, like somehow managed to expose this without making a massive short circuit hazard. Actually, don't I have a dead 1080 that I could totally like do this experiment with? I have a bunch of dead 1080s, but like absolute like I want to like because I'm wondering like what does the underlying copper look like, and how hard would it be to solder it without shorting all of it? But anyway, so absolute madness idea would be just strip away all of the solder mask, and then just smash 0402s on top of it. Just completely pack them in. Um, that might be not good for thermal stress. But anyway, yeah, I wonder about that. I really do. Because it is like, it's definitely possible. I don't think it would be very fun to do, but possible, yes. Alternatively, you could also just replace the 0402s that NVIDIA used with better ones, because you can get some wild 0402s these days. Like, I mentioned the ones that I pulled off the Vega, those are 1.2 microfarad. The 0402s on the back of a 6900 XT are 4.7 microfarad. But recently I went browsing DigiKey. They make 22 microfarad 0402s now. You can get like Like the SP caps that, you know, were originally on the back of this card. Right? Like this thing is a 330 microfarad capacitor. Like 20 of the, like you can get 20 of these that have more capacitance than an entire one of these. Right? And this is 4 of them right here. Right? So like imagine you could have like one, so you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you'd have 18 over here. You'd have with more capacitance than one of these guys. That would be completely insane. And then you could just do that all over the place. Like, I do wonder what that would achieve. Actually, you could maybe even stick them directly onto, because I think these are also 0402s, or these might be 0201s. And yeah, doing it like hot air soldering right next to the silicon, probably not the best idea, but like the possibilities are intriguing. Anyway, so yeah, so while I think like what I ended up doing, I think was kind of pointless. Mostly because I think like with how much effort this took, I really like. Here's the thing: my initial thought process was like, "Oh, it's not going to be that bad. How bad could it possibly be to solder some 0402s?" And then I'm sitting there with the hot air, you know, tweezers in the hot air in one hand, tweezers in the other, poking at these stupid things to try get them to stop shorting each other. Because like that was a real problem. Is like they'd like if they just touched each other, they would just blob, and then you couldn't separate them, and it's. Ugh. Horrible. Absolutely horrible. Um, anyway, so, you know, like I thought it would be easy, and then I'm sitting there with just and it was not easy. And now I regret and that's why I was like, oh, I'm not, you know, I like it'll be easy. I'm not gonna bother with using some like super fancy capacitors, but then it's like, man, if I had known how much effort it had taken, I would have at least wanted to use some fancier capacitors. Because with these being 1.2 microfarads each, I don't think they made that much of a difference to the measurements. But anyway, I did end up doing that. I did also briefly consider sticking an extra capacitor right over here. Because, again, the main limitation for me was the backplate. But right there is a gap. Right? There is a gap. I think it would have looked kind of stupid, though, if there was just like one extra capacitor right there. Anyway, you can also see that the SP caps that I ended up stacking, like that was a sort of big priority for me, was to make sure that they didn't, you know, cause any compatibility issues with the backplate, which I succeeded in. This one is ever so slightly taller than the backplate is. Because the funny thing is, those 330s that EVGA uses, they're actually thinner than the 470s that I use. They look almost the same height, but they're not. The 470s are very, very slightly thicker, and it is noticeable because, yeah, these sit below the backplate. This one is like flush or slightly higher than the backplate. So that's kind of annoying. I mean, it's not actually a problem. I don't consider this a failure, but yeah, like that's just like a thing I noticed. Anyway, and then with the 0805s, I could have totally extended this way out there. I just didn't. I might go back and do that anyway. I'm not sure if I'm going to measure it again, though, but I could. And also, I could have squeezed in an 0603 over here. Not another 0805, because that would hit this capacitor. And I'm pretty sure, like, I think this side is Vcore and this is ground over here. Because this is, yeah, this is almost certainly memory power on this side. So, yeah, that's kind of that. This was nice and easy, right? Like, so this right here, very easy to do, not a big deal. But also I don't think it made that much of a difference. So, you know, that's kind of, yeah. Oh, well. I mean, they don't hurt, but like, I think a lot of the improvement is just the extra SP caps. Because like in my past experience with cap modding, you usually need a lot of extra capacitance to get a measurable improvement. It's not like, oh, I'm gonna add like 10 multi-layer ceramics and it's gonna do something. It's like, nah, you're gonna add like a few. You need to add like, well, the funny thing is, I didn't actually add that many SP caps either, right? Which is why I'm so surprised I saw such a huge improvement. Because if you think about it, we have a 470 back here, but the Hall of Fame has a 560, right? So it's like, okay, so we have like plus 110, right? Because this used to be a 330. This is plus 330. So this is plus 140. Um, this right here is plus like 470, and then the 330 that got replaced. So that's like 140 plus 470. So that's like 570, 620? No, 610. All right, so plus 610, and then we have plus 470, plus 470. So that's really not that much, right? Like, compared to some of the other cards that I've modified, like, I've packed way more capacitance onto some other cards with way smaller, or, yeah, without, like, very significant improvements. And so I'm honestly kind of surprised that, like, so maybe the ceramics contributed more than I thought they would. Um, but the issue is, like, I didn't go in in a process of like incremental steps of adding capacitors. I went from unmodified to this. So I don't know like how much each set of capacitors actually made, how much of a difference each set of capacitors made individually. Um, which is a bit of a shame. But here's my counter argument. I can still, like, in this like testing phase, what I could do is like I could just add some more capacitors, right, without worrying about the backplate compatibility, and just uninstall them afterwards to see, like, um just like more, like do some more scientific, like more like just scientific experiments where it's like I no longer care about backplate compatibility. We'll just throw the kitchen sink at it, see what happens, and if it's like a big improvement, then start thinking about how do I get the kitchen sink to fit under the back plate. Because I'm not going to be happy about having to uninstall it. But yeah, because this is like permanent cap mods, whereas like temporary cap mods is like, oh, you have big extension wires for your SP caps, and because then you can just like desolder the extensions and you're good, right? Also, it's worth noting that those wires add some equivalent series inductance, so they somewhat negatively affect the effectiveness of the capacitors, but it shouldn't be, like, in my past experience, it's not that significant. Like, you can run some pretty serious extension wires, and the capacitors at the end of it still help a lot, depending on the card. Now, obviously, if you start with a card that has really good voltage regulation right out of the box, yeah, that's not, you like, there's a limit to how good the voltage regulation can get, especially if the card has V droop. But these are 1080s, and the 1080 classified especially doesn't have V droop out of the box. Like, you would have to add that intentionally yourself. Out of the box, this thing has no V droop. So, yeah, I am kind of toying with the idea of maybe doing some like less aesthetic, like less limited modifications, um, just to see like how far could I push this, right? Because it's like, okay, we shaved off 20 millivolts of worst case scenario undershoot. Could I shave off another 20 if we just pack like another, I don't know, 3,000, 5,000 microfarads behind the core, like directly behind the core, right? What if I'm not going to stack multi-layer ceramics because uninstalling that sucks. Like, it really sucks. I don't want to have to do any more hot air soldering on this card. Um, but we could, like, I could extend this, and I wouldn't even have to uninstall that, right? Like, that doesn't actually cause any compatibility issues with the backplate. Um, I could maybe look into adding some ceramic over here, then on the front of the card. So, like, I could take this further, um, but I'm just not sure about it, right? Extend this out. Like, we could really extend this out. There's so much space. I could maybe even run, like, a wire like this. Right? Maybe actually just scrape the solder mask over here, put more capacitors. Man, This is really frustrating. I've reshot this video several times because it keeps going overtime because of me discussing like hypothetical further modifications. And look at me now. Guess what we're doing? Discussing further hypothetical modifications. Well, okay. I guess I'm giving up. We're not reshooting this again because evidently I can't keep my mouth shut. Because when I see when I see space on the PCB unoccupied by capacitors, I see an opportunity to think about more capacitors. But yeah, like there could be more, right? Maybe also scrape the solder mask to get a better connection over here. And at this point, since we're going full theoretical, what about a power bridge? Right? Like just run some. I'm not sure if this would fit, but like also like an extra ground connection because like there's like limited vias over here, and it's like so. Then again, though, we really want the connection to go to the core, so I don't see how this would tie these capacitors better into the core. I don't think it would actually locally provide any benefit. Probably. I'm not sure. But yeah, like you could stick power bridges. Funnily enough, this PCB is actually kind of thin. Like when I was doing the hot air soldering behind the core, like this PCB really isn't that heavy. Honestly, I wouldn't be surprised if the 1080 classified had the same layer count as a reference 1080, which would be kind of disappointing. But like from the way the soldering behaved, like yeah, this didn't feel like a high layer count PCB. Because you can tell when you're soldering on some like high power, high layer count PCB because nothing like it doesn't like the heat just doesn't like the whole PCB is just this massive heat sink. So the soldering is like ridiculously difficult. This wasn't, which is like a very clear indication of like, yeah, this probably doesn't have that much copper in it. Because PCBs that have a lot of copper in them like suck down heat like no tomorrow. And this really wasn't very hard to solder on. So, though I didn't bother to do a measurement of like how much voltage drop there is from like the VRM to the core, but it could be actually kind of substantial if this really is the same layer count as a reference 1080. That could actually be a pretty substantial amount of voltage drop. Though I don't think it would necessarily matter that much for the voltage regulation. Because like the VRM control, like yeah, I don't think it would necessarily make much of a difference. And it is an annoying modification to do, relatively annoying modification to do. So then again, if I just do it temporary, nah, but then I'm gonna have like ugly solder blobs all over the VRM, and it's just nah. Okay, I'm not doing that. But anyway, so yeah, so that's the modifications that I did make to the card, and some modifications that I could make to the card. I'd say this was really successful. Like I am honestly like I am surprised that like because I have cards where I've gone way further, like way more SP caps, way more multi-layer ceramics, way less of an improvement. And here it's just like, yeah, you just throw like 540, 470 microfarad SP caps behind the core, and it's just like huge uplift. And then some like MLCCs that I pulled off of EVGA, and it's just like, whoa. You know, I mean, 20 millivolts undershoot isn't that much of an improvement, but like, yeah, like this is pretty substantial. Then again, like a lot of the other cards that I've tried to modify do have V-droop, and that really puts a limit on like how good the peak to peak can get, right? Because at some point, all of the difference in voltage is the V-droop itself. It's no longer like like it's no longer undershoot or overshoot. It's just like within the load line. So yeah. Anyway, that's it for the video. Hopefully you found it somewhat interesting, if not particularly useful. I can't imagine many people want to modify their GTX 1080s for marginally better overclocking behavior. But well, it is worth noting that these modifications do get more significant the higher clocked the card is, right? Because obviously the more power the card is pulling, the bigger the transients are, the more significant the effect of the modifications gets. But yeah, like if you're on air cooling, I don't really think this would be even remotely worth it. Would it? Well, if you're on a reference 1080, the voltage regulation is probably even like much worse. Um, so if you're on a reference PCB, it's a different matter. It actually might be significantly more worth it then. But on a classified, not really, in my opinion. Though I also didn't go as far as I could have. So yeah. Anyway, primarily like I like doing this. Also, I do plan to bench this card. I really want to do like an SLI setup with the Hall of Fame, and then once I get the other two dead like broken 1080s, I have like the issue is I don't have a spare VRM for them because they need a yeah. Anyway, um, maybe a 4-way SLI setup as well could be fun. And so I do want all of the cards individually able to clock as high as possible, right? Because especially when you have a big stack of cards, whichever card clocks worst is what you're stuck at, right? Like that's what you're running for all of them. Um, so having the best possible power delivery on every single card kind of, you know, uh, helps with making sure that they like you can reach the highest clocks for in when you have the full stack of them together. So anyway, yeah, um, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with actually hardcore overclocking. I do have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. I've also got a Bandcamp. There's a link to that in the description. And, oh, I'm also developing a game. If you'd like to check that out, there's a link to that in the description also. So, yeah. And that is actually it for the video. So, thank you for watching, and goodbye.